Welcome to How AI Happens, a podcast where experts explain their work at the cutting edge of artificial intelligence. You'll hear from AI researchers, data scientists, and machine learning engineers as they get technical about the most exciting developments in their field and the challenges they're facing along the way. I'm your host, Rob Stevenson, and we're about to learn how AI happens. Here with me today on How AI Happens is the head of AI over at SmileIdentity, George Williams. George, welcome to the show. How the heck are you today?
I'm good. This is great. Thanks for having me. Really excited about doing this interview.
Yeah, really pleased to have you for a multitude of reasons, not the least of which is that you have some interesting ideas about how long AI has been with us. And it's funny, every time I speak with someone, the dawn of AI gets a little earlier. You know, I'll speak with people and they'll say, I've been in this space since the 80s. Rob, I bet you didn't even know AI was a thing then. But you believe the genesis of AI is even earlier than that. Is that fair to say?
Yeah, you can go back in history. I think in modern times, depending on which AI researcher you talk to, we're in our fifth big wave of artificial intelligence since computing started with Alan Turing in the 50s. In fact, some of the seminal words and concepts that we use even still today, like the Turing test, that came from Alan Turing in the 50s. But if you actually look through a lot of the literature around anthropomorphism, around detecting humanistic qualities in other things, in animals, projecting humanistic qualities onto other things like robots and automatons, you can actually go all the way back to the Greeks, where Aristotle actually wrote a lot about being able to separate the spirit and the material world and being able to impart human qualities on objects that can act in a humanistic way. And so robotics, you can trace all the way back to the Greeks. And in many ways, robotics and artificial intelligence are very much intertwined. So yeah, I like to go all the way back to the Greeks for sure.
That is a fascinating perspective because the simplest definition I've kind of come across for AI is that we are replicating human cognition, human consciousness. And that's what Aristotle was on about when he's talking about personification of objects. Is like, can we take what it is to be human? What is this knowledge and this human spirit? And can we project it onto other things? Isn't that what we're doing? We're just, instead of projecting it onto an animal or a table, as Aristotle would have said, we're projecting it into a server farm or into devices.
Sure. I imagine, if the Greeks had the level of technology that we have today, they might have been able to run with it. And they might have created pure robots in ways that we couldn't even imagine today. They were advanced in a lot of their own ways, but they had a lot of stacks of technology in which they had to build. And unfortunately, they didn't. It took another couple of thousand years, but here we are today talking about imbuing machines with humanistic kinds of qualities like cognition. And, it really seems like it's closer than it's ever been. It's a really exciting field to be in right now. I've been in technology for over 20 years now, and I'm just more excited to be in technology now than ever.
If only Archimedes had had a big enough lever, am I right?
Yes, exactly. Yeah, very good.
That's an ancient Greek joke for none of you out there. I think that was just for you and I, George. But in any case, SmileIdentity certainly has a big enough lever. Let's talk about what you're up to now, George. I'd love to hear a little bit about you and then what you're up to now in your current project.
Sure. So a little bit about me, as I alluded to earlier, and as all the gray hairs sort of are proof of, I'm a Silicon Valley tech veteran. I've been in this industry over 20 years. And, I think it's interesting, during that span, I've kind of split my career up into two parts. So first half, I was a pure software engineer and manager working mostly in startups and R&D in the Valley. That was the first half of my career. Second half, I returned to my first passion in mathematics. And that's when I really started to embark on my career path in data science and machine learning. And these days, the incarnation of all that, or the umbrella of data and data science, machine learning, which is artificial intelligence. And currently I lead an AI team, and we work on computer vision-based biometrics, companies called SmileIdentity, and we apply these techniques to biometric authentication. So our customers and our partners use our service. So instead of passwords, right, they use their face, they use their ID cards in order to authenticate themselves online to various kinds of services. There are a lot of companies in this area. It's a very exciting area. Our focus is mainly on right now the continent of Africa, which is undergoing a major digital transformation, much like the dot-com days. If any of you remember those times in the early 2000s in the US, that's happening right now in Africa. And they're sort of leapfrogging. They've learned from our mistakes the last 20 years, and they've gone right into, they're skipping passwords and they're going right into advanced biometrics. And so we've launched our service. We've been in Africa for about 5 years, and we're in 52 out of 54 countries in Africa, and we're slowly migrating north, and we're going to be in the Middle East as well. So that's SmileIdentity, and that's what I do at the company.
Given your salt and pepper bearded veteran tech status, what made you decide to work within the biometrics vertical?
It's interesting thinking about this earlier before the interview. I was going back in time. And what I did, I talked about like my career path. I had sort of two different, the system side and the stochastic side, I like to tell people. And so midway through my career, I decided to take a break from the Silicon Valley life, working at companies, working in industry. I joined a research lab at New York University and the Courant Institute of Mathematics. And the research group I joined was called the Human Movement Lab. And we explored computing and mathematical techniques at the intersection of video analytics and human motion capture. And so a natural evolution of this work included finding the best algorithms that could be leveraged for things like face detection, face verification, voice-based speaker identification, and gait recognition. We worked on all sorts of crazy ideas. They were crazy at the time. And our lab was famous for training machine learning models that could automatically identify celebrities and politicians in low-res YouTube videos. This is like 10, 11 years ago. And so looking back on that, a lot of that work we did was seminal research in computer vision and deep learning-based biometrics that is more commonplace and commoditized in products and services that I help build today. So I really love applying mathematics and computing to all sorts of problems. And I think biometrics is a fun and challenging vertical to leverage these techniques. And I think it's super rewarding to see the fruits of the early days of those research days and now to build useful and important biometric services, such as the ones my team is building at SmileIdentity. So that's sort of a brief path through my path in biometrics. So it started out with some core research, and I've moved that into a mature stage, building these products from that research today.
So is the main use case now user authentication? Like, we were going to replace passwords, or how would you say it's going to impact the average user?
I'm a bit biased here since my company builds passwordless biometric-based authentication technology. I'll just say that in my daily routine, I leverage biometrics as much as possible, and I prefer this over passwords when I can do so. So I unlock my phone with my fingerprint. I unlock my laptop with my face. I bypass airport security with my eyes. I use the Clear biometric service. So personally speaking, I'm all in with biometrics, but I'm not an outlier. I'm not alone. A lot of tech people and non-tech savvy people have embraced biometrics in their daily life and their routine. And this continues to trend upward. So, I think the writing is on the wall here. I'm pretty bullish on this prediction, but I think in the next 5 years, I believe biometrics will surpass passwords as the most commonplace authentication mechanism for devices and for online services. So this could either be gradual over the next 5 years, or there can be an abrupt event which causes a mass shift to biometrics. For example, we've seen a lot of these advances with quantum computing over the last few years. And one of the interesting results of this so-called quantum supremacy is that a functioning quantum computer will be able to break the standard encryption protocols that we use today and reverse engineer almost any password within a matter of seconds. So I think a stunning development like this could prompt a dramatic shift in the adoption of alternate authentication strategies like biometrics. So I think it's going to happen, and I think it'll happen fairly soon.
When it comes to using biometrics, you gave the example of unlocking your phone with your fingerprint or using your retina at Clear at the airports. I'd love for you to help me remove my tinfoil hat a little bit because I am a huge TSA PreCheck fan. I try not to speak about it because I don't want everyone to sign up and then ruin it. But I have not done the clear thing because I'm like, I don't want to give them my eye. I don't trust the government, you know? I don't want to be like too conspiracy theory, but I'm like holding back a little bit. I feel the same with my fingerprint. It's like Apple already has so much information about me. Do I also want to put on top of that my fingerprint? What do you think about that point of view where it's like I'm just unwilling to concede parts of my personal biometrics to big companies or agencies?
I tend to take kind of a cynical view on this. And I like to tell people it's like, all of your data is already out there in some form or another. I remember early days in tech, I used to joke with my colleagues. It's like all this technology we're building, right? And those were the early days. This is even before cybersecurity was even a thing. And we would joke at each other. It's like, yeah, I hope one day everyone doesn't doesn't give up all of their data to these databases and these services. And fast forward to today, and we readily give up our data. Sometimes we know we're giving it up, and in other cases, we don't realize that it's being exchanged. So I think we've reached a point of no return with our data. And really, the question is, who do you trust with your data? And what kind of policies and implementations are in place to protect people and their data and their privacy? So I think really there's no looking back. We live in the world in which we live in. It's not possible to really live off the grid anymore. And so as consumers, as people that use these services, we just all need to be very aware of the technology that underpins all of this. We have to be technologically savvy. We don't all need to be software developers or ML engineers, but we all have to understand the technology that's powering all this, and we all have to ask the right questions. And these days, we have to be involved in a lot of the laws and regulations that are surrounding a lot of the technologies that we are building. So that's kind of my cynical answer to your question. But data privacy, I think, is just one of the challenges around all of the technologies we're building around authentication, whether it's password, whether it's biometrics, privacy, ethics, transparency. These are important challenges that I think society in general, not just the technological community, but society in general is coming to grips with. A lot of challenges around these technologies. I'd love to talk more about those challenges if you'd like as well.
Yeah, definitely. One would just be ongoing security. And you sort of mentioned a little bit about that when you gave the example of a quantum computer being able to crack even a sufficiently advanced text-based password. Wouldn't it just be a matter of time till that quantum computer could also point itself at biometrics, or is biometric authentication just an order of magnitude more complex?
Yeah, quantum computers, at least for the near-term algorithms, if we look at some of the algorithms that we can enable, right, once we can stabilize these qubits, breaking standard encryption is already an algorithm that once we get a quantum computer, we know it will start to break encryption. Now, some of the other things like completely secure zero trust communication, quantum machine learning, I think there's a lot of theories and research about how we approach these things, but no robust algorithm yet. But breaking standard RSA-based asymmetric encryption, right? We know that we can do that with quantum computers. A lot of these other things are still up in the air if a quantum computer can solve them, or if a quantum computer can solve them can do it more efficiently and quicker than a cluster of supercomputers. So I think the differentiation is important when we're talking about like authentication and breaking authentication. But biometrics is super interesting because in addition to, I think, some of the systems problem, it does have some challenges with respect to bias, because we are leveraging machine learning, transparency, because we are leveraging these days deep learning, and deep learning is well known for being black box in the sense that we aren't 100% sure what these super powerful algorithms are doing. And then there are a lot of the ethics questions around the use of biometrics and mass surveillance. So it's interesting, as we move towards biometric systems, we do get into another set of I think interesting challenges compared to existing password-based and systems-based kinds of authentication techniques.
I'd love it if you could outline the specific challenge with regard to bias? Because it seems that if you were just trying to identify one individual, bias wouldn't necessarily, like, as long as it could say it was this person, is the bias that much of a problem? It would only become if this technology was being used to identify large swaths of people at the same time that bias might be problematic. Is that a naive way of looking at it, or what is the scope of the problem there?
No. Yeah, I think you hit the nail on the head. So for many, many, many years, so let's talk about the bias thing first. For many years, the main challenge with biometrics was accuracy. So even before I started doing research in these biometric algorithms 10 years ago, face recognition was a thing for many years. I actually talk and blog about like the history of face recognition. And the early systems of face recognition were laughable. Face recognition, fingerprint identification, iris recognition. A lot of this research was done even 20, 25 years ago, and the accuracy was super low. Fast forward to today, so now we have commodity neural network based algorithms that have improved the accuracy dramatically, and in some cases exceed human level performance. And I've seen this firsthand, by the way, at my company. So in general, accuracy of these machine learning algorithms is no longer the challenge. And so I think from a mathematics standpoint, from an algorithmic standpoint, we're pretty good. But you've probably heard the saying garbage in, garbage out with respect to machine learning and especially deep learning. And that's very true with biometrics. And most biometrics algorithms, the underpinning is a neural network. So garbage in, garbage out. What do I mean by that? So for example, if your face recognition training data is only white faces from Western countries, your machine learning model, your biometric algorithm will not be accurate if you deploy it in Africa or the Middle East. We tried. And that's a big problem because a lot of the seminal work, like when I was doing it 10 years ago, right, the data sets we had were white men, and they were like white men, white celebrities. And so a lot of the data sets that we worked with very early on, and in fact, the ones that you will find publicly available if you wanted to train one of these models yourself, right, they still have this ethnic and racial bias. And so this training bias, right, is really all about the bias that's in the data set and the data that was collected and who collected the data. And it's something that the biometrics ecosystem continues to deal with. I know firsthand, as I mentioned before, my company deploys face verification solution in Africa, and we're pushing into the Middle East. And we spend a large amount of our effort and resources curating the right data sets to train our algorithms, which I think are the best ethnically unbiased algorithms in the industry. So this is still a problem. So that's a kind of a mathematical problem, but it now gets into like a societal and ethical problem because a lot of people feel like a lot of companies, a lot of government entities, a lot of governments, right? They feel like this stuff is good enough to deploy, but they don't necessarily ask the right questions about this ethnic bias. And the research community, I think, is closing the gap quickly. But we still we go into, like, we talked to some of our partners and they said, yeah, we tried your algorithm, our data. It's like, it's really good. Thank you. But, we tried out a bunch of these other solutions, right, that purport to have high accuracy and unbiased data, and we find that the truth is different. So we're still dealing with a lot of these issues, especially internationally. In the US and in Europe, we're finding that we tend to be a bit more advanced in how we're thinking about this and the questions we're asking. And in fact, finally, the government, the US and European governments are starting to incorporate, right, some of these issues and baking them into various laws. So there are various laws now that prevent in the US and in Europe from capturing your biometric data where you have to opt in, right? You have to explicitly opt in before someone collects your data. And that's a good thing, but that does not exist everywhere in the world. And the world is quickly moving to deploy biometrics for mass surveillance. So, for example, on the one end, right, we have, Western countries that are kind of dealing with this and coming up with legal frameworks to deal with this. On the other hand, it's the wild, wild west with respect to deploying biometrics, and it's an ethical concern. For example, I'll bring up the mass surveillance projects in China, where they are actually profiling certain parts of their population, certain parts of their society, and automatically restricting services depending on ethnicity. In the best case. In the worst case, they are detaining people based on their inferred race. And this is happening now in certain parts of China where they leverage mass camera surveillance to locate Muslims and detain them for quote unquote re-education. And so it's very exciting, right? The technology, and I think it's fun and challenging to apply this math. But at the other end, putting my ethics hat on, I'm very concerned that we don't have the right frameworks in place to be able to guarantee certain rights to citizens across the world with respect to this technology. It's getting better in many parts of the world, and I think it will get better over time. But the technology is imperfect in ways that make me uncomfortable, and this technology is being deployed at massive scale in many parts of the world. And that should be a concern for, I think, all of us.
When you say that your algorithm is more unbiased or is sufficiently unbiased, how would one go about measuring that?
Like I mentioned, we curate specifically for the countries that we go into. Even different parts of Africa are very different. And so before we go into a new country, we have a team of account managers on the ground that help us collect the right kinds of data. We work with our partners because in many cases, we aren't the first biometric company that a partner has used. I mean, they have a lot of critical feedback based on their previous experience with biometrics. And so we gather all that feedback. And for the cases where it's not a system problem, it's a machine learning problem, we know that we need to curate specific kinds of data that will address that particular partner's concern in that country. And so we've done this many times. We have a way to measure our accuracy in very specific ways. We actually measure not only our pure face recognition, our biometric accuracy, but we have different kinds of benchmarks that we leverage for different kinds of ethnic groups and in different kinds of situations as well. But a large area for us is different benchmarks around ethnicity. So that's one thing. But in machine learning, I think most people know these days that once you train a model and deploy it, you're not done. In fact, that's really the start of a life cycle of activity that you have to maintain and sustain in order to have really good AI for biometrics. So we're constantly monitoring our models. We're looking for where our models may be weak, and we have a pipeline in place to curate more data. We have human labelers, human reviewers that also surface issues in our pipeline, right? If we need to update a model, we can do that very quickly and deploy updates. And so these days, with any kind of AI, you need to constantly monitor and update, and you need to have an operations pipeline that can be able to deal with rapidly changing conditions of how your model needs to operate accurately. And we employ such a model. In fact, we were doing ML ops before ML operations was a word. But I think for biometrics, that's very important. That's very key, not just for ethnic diversity and accuracy, but also for fraud, because the fraud landscape changes very quickly. So that in general is our technique. And of course, right, we're heavily involved in research. So there's a lot of state-of-the-art stuff happening. Every few weeks, there are many computer vision AI research conferences, and we engage with researchers. We're up to date on the latest papers, and we review those, and we capture a lot of the latest research that's important for us in order to meet our stringent benchmarks for biometrics. So at a high level, that's kind of our strategy, is constantly monitor and update.
How is MLOps deployed within fraud detection?
So, I think fraud detection is interesting. So first, I will say that if we look at, and we talked about password versus biometrics earlier. So the first thing to emphasize is that biometric authentication fraud is really different than sort of password-based fraud. So password-based fraud systems are vulnerable because either systems allow weak or reused passwords or require such a complex password that people end up writing them down on Post-its. They still do that, or constantly are resetting them. So these are sort of system and policy vulnerabilities, and they're still commonplace even today. Hackers and bad actors know how to take advantage of them. Multi-factor authentication can resolve some of these issues, but they add more friction to the login process. And we're actually starting to see a lot of successful hacks in the MFA space involving text message hacking. So Fraud in biometrics is very different, has a very different shape. For example, it's fairly easy to find images of people's faces online, such as via social media posts or dating apps. And we've seen cases actually where fraudsters locate their victims physically in the real world, take a picture of them, either without their knowledge or through some kind of social engineering, and then present that image to our face matcher. So, what we've done is we've implemented several countermeasures to combat this kind of fraud. So, in addition to a face, we require users to demonstrate so-called liveness at the point of capture. So what does that mean? So our algorithm ensured that the image was taken with the user's smartphone at the time and place that the authentication attempt was made. We have a lot of proprietary technology that we've implemented for this. And we also detect certain kinds of video injection, hacking of kind of the software in the SDK. And more importantly, we capture a short video instead of a single image. And so this extra dimension enables us to detect many kinds of fraud, including single stolen images, many kinds of synthetic and static forgeries. And we also train our models against sophisticated kinds of forgeries like deep fakes by training on images. And it's a form of adversarial machine learning, if you've heard of that. And we train on specifically those images created by the most recent kinds of generative AI and deepfake generating algorithms. All of these algorithms so far today, they leave telltale signs and artifacts, either in the pixel space or in the scene reconstruction, and they can be detected if you specifically train for them. Another countermeasure is that we do have a team of human reviewers and human experts that are also looking at the stream of data. I mean, we can spot new kinds of forgeries as they start to appear. And like I mentioned before, right, we have a pipeline where, all right, we have new data, we have new labeled data, we need to retrain our models. We incrementally retrain our models and we update our models as soon as we need to. And having this ML pipeline already in place where it's like detecting that we might have a new kind of fraud, having human reviewers actually verify it, label it as a new kind of fraud or a repeat of an existing kind of fraud, which we've already classified in the past. That's extremely valuable new labeled data. And then from that, we have another process that automatically kicks off a new training job. And once that model meets the benchmarks that we talked about earlier, that gets updated to our servers, which are serving those models. And so it's a fairly standard from a 360-degree life cycle perspective. I think it's fairly standard what we're doing. Not all companies that claim to do AI machine learning are capturing a life cycle of ML ops, but I think a lot of companies will need to get there. I think for biometrics, we had to create this very early because we saw the need and we saw the biometrics landscape, the fraud landscape, our need to update based on new ethnicities, based on new geographic regions that we're entering, right? We had to sort of deal with that early. We had to create our own pipeline. But these days, right, you start an AI startup, it's an AI company, right? You can already get a platform that has a lot of these concepts and this pipeline, this life cycle baked into it. So yeah, I think it's pretty exciting what's happening in the ML ops world. But that's kind of what we do to ensure that, we're serving the most robust models that we can to our customers.
Fraud prevention sounds like an endless game of whack-a-mole, right? Because whenever this is sort of an old truism in tech, whenever some guardrails are put up or some sort of restrictive monitoring tech is built, there's a workaround being formulated at the same time. Is that how you look at fraud detection specifically?
Yeah. And, I think the malware analogy is very apt because as we've learned with malware, and I was in cybersecurity, I've been in cybersecurity also, as well as being in biometrics. Yeah, as soon as you come up with a countermeasure, it's pretty straightforward to, the fraudster can make a few small tweaks, right, in their code, which shifts the binary fingerprint in such a way that now the countermeasure you've spent all this time building, right, is fooled. And so fortunately with biometrics right now, we do leverage, I think, a lot of what we've learned with that experience. But you're right, it's a game of whack-a-mole and the whack-a-mole game in this case with biometrics, right, is slightly different because it is so machine learning based and not necessarily systems based. Now the focus is not on code paths, right? Now the focus is on the weights in the neural network and protecting the neural network, or in understanding the mathematical vulnerabilities that can exist in machine learning. And so this is a very new area of security. And in fact, a lot of cybersecurity specialists don't know much about mathematical vulnerabilities in machine learning. I speak at a lot of conferences, at cybersecurity conferences, and I've been telling people, like, this is coming. You better know your math because the vulnerabilities are mathematical. They're not systems. Those were early days when only a handful of companies, even large companies, were deploying models at scale. But today, I think ChatGPT, I think you brought that up earlier, right? Now CEOs and your average non-tech person, right, now knows about chatbots, and they're experimenting with OpenAI's latest models. And because of that, there is, this is like in the past couple of weeks, it's crazy. There's this massive rush to get some of these models right into our phones. Microsoft has just recently announced that they're going to take all of these OpenAI models and they're going to put this in, Microsoft Excel and in Microsoft Office. And so we are reaching a whole new level of mass adoption with these black box models. And we don't know exactly all the vulnerabilities. In fact, I think we know less about the vulnerabilities in machine learning and deep learning that we do with, I think, your average piece of malware. Now, your average piece of malware, right? Malware has been around for 15, 20 years. So we know a lot about the shape of that data, but much less is known about the vulnerabilities of models. So you're going to be hearing a lot more about this, I think, in the news regarding cyber attacks that leverage mathematical attacks, model attacks, training data attacks. And this is new for a lot of people in the cybersecurity industry. For us in the biometrics, we've actually worked with a lot of the researchers in this area through techniques like adversarial machine learning, right? We can mitigate a lot of these things. But I think in general for the industry, for cybersecurity, in the security industry in general, this is very new and everyone's going to get up to speed very quickly.
It's exciting. It's terrifying. We certainly live in interesting times, George. And this has been a really interesting conversation. And so here, as we creep up on optimal podcast length, I would just say thank you so much for taking the time. I've really loved chatting with you today.
This has been fantastic. And thanks to you and thanks to your audience for being excited and interested in artificial intelligence. It's going to be a wild ride.
How AI Happens is brought to you by Sama. Sama provides accurate data for ambitious AI, specializing in image, video, and sensor data annotation and validation for machine learning algorithms in industries such as transportation, retail, e-commerce, media, medtech, robotics, and agriculture. For more information, head to sama.com.